When you hear forces and energy, you probably think of complex physics, right? Well, today, we're looking at something even more brilliant. Not just understanding these ideas, but figuring out how to teach them to an 8-year-old. We're going to deconstruct a masterclass in education to see exactly how it's done.
Everything we're about to explore is driven by this one single question. This isn't about memorizing facts from a boring textbook. It's about making science real, making it something you can touch and see, using the stuff that's already in the world right around you.
So, here's our game plan. First, we'll look at the big challenge itself. Then, we'll cover a few core concepts, the basics. After that, the fun really starts with hands-on activities. Then, we'll see how a great teacher turns that play into real principles. And finally, how it all ties back to a kid's everyday world. All right, first things first, the challenge. How in the world do you explain something invisible, like a force, to a third grader? I mean, you can't actually see a push or a pull. You can only see what it does. And that, right there, is the puzzle we're about to solve. Okay, so before we can start playing with toy cars and ramps, we've got to lay a foundation. Every great lesson starts here. We need some building blocks, a shared language. There are 3 big ideas that everything else is going to be built on. Big idea number 1, force. It sounds complicated, but it's not. It's just a push or a pull. That's it. This is our starting point, the simple action that kicks everything off. Next up, motion. And this is just the result of a force, right? It's the part we can actually see. Something was over here, and now, poof, it's over there. That's motion. Simple. And number 3 is energy. Now, this one's a little bit more abstract, you know? The best way to think about it is like, it's the juice. It's the power that lets you create a force and make motion happen. Ah, and here's the secret ingredient, our little plot twist. Friction. It's another one of those invisible forces, but this one works against motion. And the cool part is, the students aren't just going to be told this definition. They're about to discover it all on their own. And that brings us to the best part, the discovery zone. This is where all those abstract definitions suddenly become real, tangible things you can feel and see. It's all about learning through carefully designed play. Now, this is really important. The play we're talking about isn't just random chaos. It's actually built on this really smart teaching method called the 5E model. It's a journey. It starts by getting kids curious, that's engage, lets them explore, and takes them all the way to a deep understanding by the end. So the first activity is just beautiful in its simplicity. A student gets a toy car, they push it. Then they pull it with a string. And they're asked one simple question. What happens when you push it harder? They're literally feeling the concept of force with their own hands. And get this. This is the incredible result. The student connects their own action directly to the science word. They didn't just read the definition of force. They basically created it from their own experience. How cool is that? Next up, it's like a mini tug of war. Imagine 2 kids pushing on a box from opposite sides. This little chart shows exactly what they figure out. When the pushes are equal or balanced, nothing happens. But as soon as one kid pushes harder, unbalanced forces, the box starts to move. And there you have it. This simple sentence is actually a profound scientific principle. These kids just figured out one of Newton's laws of motion without ever even hearing his name. It just makes sense to them because they just did it. Okay, remember that secret ingredient, friction? This is the grand reveal. The students roll the same toy car on different surfaces. And you can see the results right here. On a smooth tile floor, the car goes really far. But on a rough carpet or out on the grass, it barely moves at all. And that is the aha moment. The students realize there's some invisible thing slowing the car down, something to do with how rough the surface is. They've just discovered friction. And I love their wording here. Use up motion. What a perfect, intuitive way to describe it. All right, final experiment. And this one is designed to make that abstract idea of energy completely visible. You put one car at the top of a ramp, it's got all this stored up energy, you let it go, it rolls down, and wham! It collides with a second car. So what happens next?
The kids see it plain as day. The first car slows way down, and the second car zips forward. They literally saw energy move from one object to another. And even better, they noticed the sound of the crash and realized that some of the energy turned into something else. That is a seriously sophisticated observation.
So the students have played, they've explored, and they've definitely discovered some amazing stuff. But the learning doesn't stop there. Now comes the really critical part, connecting all that fun back to the big scientific ideas. This is where a great teacher works their magic.
And this is how it's done. First, the teacher has the students explain what they saw. Then, they push them to go deeper, to elaborate using the most powerful tool in all of science, the what-if question. What if the car was heavier? What if the ramp was steeper? This is the moment they go from just seeing what happened to predicting what will happen. That's real scientific thinking.
So, how do you know if they really get it? Well, you don't need a formal test. You use a quick, clever little check-in like this. This simple drawing assignment tells a teacher everything they need to know about a student's understanding. It's an assessment that actually feels like part of the fun. And that brings us to our final and maybe the most important step of all. Because for any of this to actually stick, it has to matter. It has to connect to a student's real life, their own world, their community. And this is how you make it stick. You don't just talk about forces. You talk about pushing the cart at the local sari-sari store. You talk about kicking a sepak takraw ball. All of a sudden, science isn't some weird thing that happens in a classroom. It's everywhere. It's part of your life. So, what's the big takeaway from all this? We just saw how some pretty deep scientific ideas can be unlocked with just a few toy cars, some bottle caps, and a couple of really good questions. It really makes you wonder, doesn't it? If this is how we can teach physics, what does that say about the true nature of how all of us really learn best?